All right, so welcome back to this session. So in this question, rather this question that we have right now on the screen says we evaluate the following limits if they exist. So these are simple and straightforward question. I believe everyone can manage to solve them, but I'm going to go through them for the sake of understanding. All right, so we have the first question there that has been presented before us. So what you just need to do is to, for this question, what you just need to do is to plug in the values of, you plug in the value of, just put 4 inside there. So we're going to have, in other words, I'm trying to say the limit as x is approaching 4 of 9 plus the absolute value of 8 minus 2x. This one is equal to, so where there's x, I'm going to be replacing what? With 4 in this expression. So this one is going to give us 9 plus, we have 8 minus 2, we put 4 there. So when you do the subtraction, this part will give you a 0. The absolute value of 0 is 0. So you just remain with 9 there. Okay, so let's quickly move on to the next one. So the next one is the limit of the absolute value of h over h as h approaches what? 0. So how do you find this limit, or how do you calculate this limit? So like I said, if you want to know whether the limit exists or not, you have to check the what is the left and the right side of the limit and see if you're going to get a solution that is going to be the same. If you get the same solution, it means that your limit exists, and that solution is the solution of the that particular limit. All right, so yeah, so for this one, there are 2 ways actually that you can use to solve this question. If you want, you can just get okay, let me write it this way. So one thing you have to understand here is that when we say the absolute value of h, this h can either be negative or positive. So now, since it can either be negative or positive, we can say this h can either be what? Negative h or positive h. So this can be written in a piecewise function, and it can be presented as, this can be written as, okay, sorry, not this whole thing. Let me just say the absolute value of h can be written as, it's going to be positive h for all h values that are greater than 0. And then let me say greater or equal to 0. And then it's going to be negative h for all h values that are going to be less than 0. So this is what it means. This is what it means. So this h can either be positive or negative. So now, how do we apply the limits to find the solution of this expression? So now we'll start first by getting the positive h. So how do you do that? So in other words, what I'm trying to say is that I'm going to find the limit of h over h as h is approaching what? The positive side of 0. So the positive side of 0 is, the positive side of 0 can be written as 0 positive. So this is just going to be h into h. The solution is what? Is 1. Or if you don't want to do this, you can get any slightly bigger number than this h. So if this h is considered to be, okay, any number that is slightly bigger than what? Bigger than 2. Or rather, bigger than 0, this 0 that is here. So we can say the limit of that, okay, let me write it the way I wrote it, h over h is equal to, so this is just the same as the limit of, as h approaches 0 from the positive, of what? Of h over h, or let me not write it this way. Let me just write it here. So we get any number that is slightly bigger than 0. We can even get 0.1. So if we take h as 0.1, we can have 0.1 on top, and then over 0.1, because we have h on top and h down. And this will give us what? 1 as a solution. So this is how you evaluate such kind of a limit. So now it's not done. We're not done yet. So let us find also the left side of this limit. We see if it's also going to give us 1. So now the limit of negative h over h. Like I said, the left side will always carry what? A negative, because the left side of the number line is what? Has the negative, negative integers. All right, so this is what we have. So you can cancel that and cancel that. We're saying as h approaches 0 from the negative side, or from the left. So from the left. So when you cancel that, this will be h into negative h, that to just give you negative 1. Now, since the left hand side, the limit, since the left hand side is not equal to the right hand side, this tells us to say the limit of this expression does not what? Does not exist. And what is the whole point of us doing all this instead of just plugging in 0 there? Let's see what happens if we plug in 0. Let us observe this. Okay, we have the limit of the absolute value of h over h as h approaches what? 0. So let us try to put 0 there. So the absolute value of 0 over 0, the absolute value of 0 is 0 over 0. So now, if you check 0 over 0, you might think the answer is 1, but it's not 1. You might think the answer is infinity. It's not infinity. Someone else can also think that the answer is 0, but the answer is also not 0. So these are called indeterminate solutions. So anything that has indeterminate solutions, the best way to solve that is by using L'Hopital's rule, if at all you've been asked to find the derivative of that given function. So if you don't know how to use L'Hopital's rule, you can also use limits to find that, because limits, whenever you you can also use the first principle to find that. Okay, because the first principle involves limits. All right, so this is an indeterminate solution. Now let us find the limit of this expression. So how do you do that? So you first get the left and the right, you compare them. If the solutions are the same, then you conclude that the limit exists. But if the solutions are different, then you say the limit does not exist. All right, so let's quickly move on to part C. Let's see what we have. Yeah, so part C is simply just the limit of the absolute value of x minus 4, everything divided by x squared minus 16. And then this limit, we're saying as x approaches what? 4. So now how do you do this? Same thing, because we have the absolute value there. So meaning what we're going to do is we're going to first take the negative side of this limit. So let me just start a new line here. So we have the limit as x approaches 4 from where? From the left, of x minus 4, the absolute value of x minus 4 over x squared minus 16. So when you look at x minus 4, when you're approaching this expression or this function from, or approaching this number here from the left, what you just need to do is to add a negative in front there, and you change the type of brackets that you're using. So you have x minus 4 there. And then down here, this is the difference of two squares that can be written as x squared minus 4 squared. So we have on top negative x minus 4. Then down there you have x minus 4 and x plus 4. So in case you don't know what is happening, what I've done on the difference of two squares, yeah, also what are known as the difference of two cubes. Oh yeah, difference of two cubes. So you need to learn this in case you want a video where I showed people how to solve such questions or how to deal with such questions. You can simply just inbox me immediately after the lesson, then I'll send you the link. So from here we can see that you can cancel this and that because it's common, and from there the numerator becomes -1, and then the denominator is simply just x plus 4. So we have x plus 4 as the solution. Now remember one thing, we are not done solving this question. The question is asking us to find the limit as x is approaching 4. So while there is x there, we have to replace back what? +4 and see what we're going to have. So we will have something like this. So in other words, what I mean is that even this side is supposed to be the symbol for limits. So I have as x approaches what? 4 from the negative side. So When we replace 4 there, we're going to have -1 over 4 plus 4, and this will give us -1 over 8. So this is the solution for the for the third part of this question. All right, so this is the end of this question. Let's quickly move on to the next question so that at least today we can cover at least a number of questions. All right, so let's quickly look at this question, the next one. That is if you don't have any questions on this one. Okay, so this question is not yet done. I thought I've finished solving. So I've only found for the left side of this limit. We also have to find the right side of the limit. So how do you find the right side of the limit? What you just need to do is the left side of the limit, we're just going to change this part. You have a positive there. You also change there. It's going to be positive, change there. It's going to be positive, change there. So that you just cancel this and that, this and that, so that you just remain with x plus 4, 1 over x plus 4. So I have x plus 4 there. So what will happen here is, even here, this will change because we have a positive in front there. So even that one will be positive, and the solution will be positive. So now when you check the solution here, you discover that the left-hand side is equal to the right-hand side. And this tells us what? One thing. It tells us to say the limit of this function there that has been given, the limit of this function that has been given here is simply positive 1 over 8, because rather does not exist. I've just remembered that the solutions will be different because the first one that we found was a negative, the second one is a positive. So in other words, since the left-hand side is not equal to the right-hand side, so since the left-hand side is not equal to the right-hand side, if these are not equal, this tells us to say the limit of this function as x is approaching 4 does not exist. So this is also the solution. Okay, let's do one more last question, I think, for tonight. All right, so this question says, we evaluate the limits. So how do we evaluate the limits? Let me first end this video.